Okay, so think about if the angle theta between the tails of the two vectors, if it's an acute angle, then will the vector projection be in the same or opposite direction as vector B? It's an acute angle. So it's going to be in the same direction. Yes. That's the diagram at the top of the page there. Okay, so if you have this vector A and you have this vector B and this angle is theta, which is acute, okay, then this is going to be your vector projection of A onto B, and it's going to point in the same direction as B. All right, if the angle between the two vectors is 90 degrees, then what will the vector projection of A onto B equal? It's actually going to be the zero vector, yes, okay? Because again, if you think about, the vector or scalar projection formula, A cosine theta, if cosine 90 degrees, you're going to get 0, right? So the magnitude of the vector is 0. So the projection will be the 0 vector. So basically, you have vector A, you have vector B. They are perpendicular to each other. Okay. And then there's your vector projection of A onto B, which is the 0 vector. Remember, 0 vector means that the magnitude is 0 and the direction is unspecified. Okay, last but not least, if the angle is greater than 90 degrees, then the vector projection of A onto B will be in what direction? Opposite of vector B, yes. Here's my vector A, here's my vector B. This is my angle theta, which is now obtuse. And then my vector projection of A onto B is going to be like so, pointing in the opposite direction of B. When this situation happens, keep in mind, because the scalar projection of A onto B will give you a negative answer, that means that when you calculate the magnitude of the vector projection of A onto B, you need to put an additional negative sign in front of your formula so that the two negatives will cancel out, ensuring that your magnitude is always positive. Make sense? Any questions?